All right, let's start with 15 on this exam. What's the measure of angle KNM if angle CAD is 35 degrees? And this is a rhombus, so I'm going to have to know my properties here. And it's being rotated. Let me just first start there. If I rotate this rhombus, am I changing the angle measurements at all? No. Okay, so there's the first part. Just because I rotate it, it doesn't mean the angles get bigger or smaller. They stay exactly the same. So what I need to figure out is, if you're asking me what is the measure of KNM, this whole angle here, what did it match up? What was the old angle called that would have matched up with KNM before I rotated it? And the way we figure out, look at how it's written, right? It's written in the letter order for a reason. K, N, M. What would be the letter order if I go in that same 1, 4, 3? What would be the letters that match up in the other rhombus then? 14. KNM would match up with what? So K, N, M. You want to try that again? What's the K match up with? A. What's the N match up with? D. D. And what's the M match up with? C. So those two are congruent to each other. Everyone say, oh, I got that. Rotations don't change angles, and it's written in a specific order. So what I need your help with now, using your rhombus properties, what is angle ADC going to be? All right? If you know ADC, you know KNM. Anybody remember anything about the diagonals of a rhombus? They're perpendicular, they bisect each other, and there's one we really haven't talked about because we never needed it. They bisect the angles they're drawn to. So the diagonals in a rhombus bisect the angle. So if that's 35, on this side is 35. Keep going. What do I know about two consecutive angles in a rhombus? Because that angle's 70, but I'm looking for the one that's next to it. Remember that? The two consecutive angles in a rhombus are 9? Supplementary. So this is going to end up being 180 minus 70, 110. All good? Rhombus properties, and then just remember rotation doesn't change angle measurements. All right, have we done 18 yet? Okay, couldn't remember. Nope, good. All right, let's go to 18 then. Find the area of that rhombus. Ooh, all right. So this is not on the formula sheet, but going back to last unit, unit 11, anybody, I won't call on anybody to put anybody on the spot. Zach, area of a rhombus?
You make a square.
Okay, well, don't get to that part yet. I'm just assuming I know the area of a rhombus formula. That's assuming I don't know, which I will get to that second part in a minute. Area of a rhombus? It is D1, D2 with something else with it. Scott? 1/2 D1, D2. And what did the 2D stand for? Diagonal length. And they are not equal in a rhombus. They are not equal. That's the tough part of this problem, right? Is remembering the formula. The rest is easy. Watch. Go ahead, draw in diagonal BD. Do I need some fancy distance formula to find the length? No, count the darn thing. So go ahead and draw in diagonal BD and AC. Count them up and let me know how long they are. When you're ready, let me know how long each diagonal is. 12? Yep. Good job. 8 and 6. There we go. So what do I end up there? 24? All right, ready? Let's pretend that's something you didn't study. 3 weeks from today, by the way. 3 weeks from today. Let's pretend that's something you didn't study. Area formula of a rhombus. There's still another way around this problem. You don't need that formula. Real quick, I don't care what the figure is. Remember drawing a box around it? You can find the area of the box and subtract out how many right triangles do I have up here. Find the area of this one, 1/2 base times height. 1/2 base times height, 1/2 base times height, 1/2 base times height, and subtract them from the box. You can still get the area. That's any figure, guys, any figure. All right, any figure. All good. All right, last one I'm going to do with you, another part 2 question, 2-pointer. Go to number 30. Ooh, here's a vocab term we haven't talked about in quite some time. Okay, here we go, kids. Medians. All right, we'll have to talk. CE is 5. YF is 21. XZ is 15. Find the perimeter of CFX. Triangle CFX. Got to find that perimeter. All right, you ready? Let's start here. Let's start with this vocabulary term, medians. Anybody remember what a median does? Comes from a vertex and it goes to the opposite sides. Midpoint. Yes, I ask you that because now, can you tell me what the length of ZF and FX are? We just said if YF is a median, F is a midpoint, correct. So I got 7.5 on each side of F. There's vocabulary term number 1. Vocabulary term number 2. Anybody remember where all 3 medians meet in a triangle? Point C in this case. Not that's perpendicular bisectors. Close. Romeo? That's altitudes. We're getting there. We'll get it sooner or later. Centroid. There we go. They all meet at the centroid. So point C is the centroid. And anybody remember the big fact about it? 2 to 1, right? 2 to 1, meaning one is double the other. All right, the bigger one always starts at the vertex. So if CE is 5, how long's XC? 10, because that's a centroid. And we're almost there, right? All I need your help with is finding the length of CF. Well, what do we know about YF? What do we know about median YF? Whole thing is 21. And it's a ratio of, ready? 2 to 1. Can you guys find out what FC is for me now? The whole thing was 21, and it's a ratio of 2 to 1. So when you're ready, let me know. FC is 1. George, hello? 7. 3x equals 21. X equals 7. Good. So that's 7. And now I won't even ask anybody. Now you can find the perimeter. 7 plus 10 plus 7.5. 24.5 units. Whew, boy, huh? We're in for it. We got some reviewing to do. Also, just a heads up, I don't know how far you kids plan in advance, probably not even like the next 4 hours in advance, but the day before our test is a Monday. We have school off that day, but I will be here during a certain time for review if you want to come in. All right? There's no school that day. Any questions? All right, put that away. Our final topic of the year. I know, I am saddened as much as you are. Devastated. Whatever synonym you'd like to put in there. Our last topic, density. It's going to be rough today. So that's why we have a second day tomorrow to start practicing and working with other people and practicing these problems. They're going to get tough. You cannot give up on me. You got to at least 1, practice, and 2, stop me at any time and ask questions. All right, this is not going to be easy here. You guys talk about this in science still? Density? Yes, no, maybe? How dense an object is? All right. Well, there's a formula for you for density, not on the formula sheet. This is 1 of 2. The other one, surface area of a sphere. Density, mass over volume, M over V. Okay, mass over volume. Some things that you'll see that are in mass, grams. Anybody know lbs here? Pounds, kg, kilograms. That's how you know you're talking about mass. How do I know this is volume? Centimeters cubed, feet cubed, meters cubed. How do I know those are all volume? They're all cubed. All right, so does everybody see mass over volume? All right, density. The other thing, and this is why these questions are going to be so tough when we get better at them anyway, they're not all going to be in the same units, unfortunately. All right, we need to be in the same units if we're going to do density. All right, we need to be in the same units, and we'll come up with that at the end of today. All right, so let's try a basic density problem out here. I got a wooden cube. And you guys can see cube, everything's the same, right? Cube, everything's the same. All the edges are the same length, 6. And it weighs a mass, 137.8. What's the density? All right, so we have a formula. D equals M over V. Mass, that's given to us, isn't it? 137.8. Problem though, what don't I give you? Volume. Good thing we're in this unit. Think you can find the volume of a cube as I pick up this call. John, go down. No, you're good. No, he is not. Yep, no problem. Bye-bye. So I didn't give you the volume, but can you find the volume of a cube? A cube is a fancy way of what polyhedron we've talked about in this unit and last unit. It's a rectangular prism. That's all it is, right? So BH, that's all it is. It's a rectangular prism where all the measurements are the same. So how would you find the volume of this cube that's 6 centimeters on each side? Here you go, 10. 6 times 6, which is the base, and it also has a height of 6. Yep. So 216 cubic centimeters. So I plug that in for my volume, mass over volume. Rounding directions, nearest thousandth. So 3 numbers after your decimal. When you're ready, let me know. 19. Not here. Yes, here. Sam, Scott's here. Take your time. I got a little rattled there too. Good. Part 2. What type of wood is this cube made of? It has a density of 0.638, so it must be ash type of wood. You all right before I knock your socks off now? Questions about just basic finding the density? All right, here you go. I'll be honest with you, this doesn't have to do with density, but it's a volume problem though. Okay, I know the word density doesn't come up, but great problem for us. Whew, how about this room? Looks like a house, but it's actually one room in the house. And we need to cool it down. So British BTUs, if anybody's wondering, British thermal units. We use 2.5 per cubic foot of air. And then for every window, we add in another 1,000. How many BTUs to cool a room? Why is this a volume problem? I don't see the word volume up here. What up here says volume? Let's go, Jackson.
It says 2.5 BTUs per cubic foot.
Cubic foot. Cubic foot equals volume for us. All right, so I got two types of polyhedrons up here, don't I? I got one on top, one on the bottom. Name one of them and we'll find the volume of it. Here we go. Go ahead, Jackson. Name one of the top one or the bottom one. What do I have here? Cube wins all of them the same. So instead, name it rectangular prism. Yep. If all of these measurements were the same, I name it a cube. BH. All right, what are you multiplying together for the rectangular prism on the bottom? The area of the base times its height. 16. Good. 24 by 18 by the height. 9. There you go. There's your volume of the rectangular prism. I'll do it along with you. What do I get there? 3,888. And what do I have on top now that I also have to calculate the volume of? Up top, 16 again. Triangular prism. Still BH because it's a prism. Still BH. All right, but how do I calculate big B here? 13. What's the shape of the base? Oh, triangular prism, Lucy. Triangle. You ready? What's the area formula of a triangle, Lucy? Okay, can you find, and I'll get off your case, what's the base and height of that one of the triangles?
6 and 18.
Got it. That's 18 right there, and 6. Everybody good. So, hey, capital B here. Area of the base is 1/2 18 times 6. Everyone with me now? Times, I'll put it in a different color here. What's the height of the triangular prism now? That's H going in now. Big B is 1/2 18 times 6. What's the height of the prism? The distance from the two triangles. The edge that connects the two triangles. How long is the height? 3? 24. There you go. Everyone good on what I did there. B is 1/2 18 by 6, and the height's 24. Good teamwork. Good work. This volume is 1296. All good before we go BTUs. So the total volume, let's add the two B's together here. Total, 3,888 plus your 1,296. I have a total volume of 5,184 cubic feet. All right, and this is where I go nuts. Because now you have this 2.5 BTUs per cubic foot. And now some of you are like, oh boy, do I multiply by 2.5 or do I divide? And you're just going to be guessing. Some of you know, that's fine. But some of you are going to be guessing. Don't guess. Don't guess. Set up a proportion. What do I mean by set up a proportion? What's the conversion? 2.5 BTUs equals, what's it say in the directions? Equals what? 1 cubic foot. So write the conversion down. Make a proportion out of it. Where am I going to stick the 5,184? Under the feet. Feet cubed with feet cubed. And then solve for how many BTUs. Now you'll know what do I do with the 2.5. But if you're unsure, just write it. Look, that was a quick one for us. Write the conversion. Write your lines, and then write whatever you have underneath. So here's what I have. 5,000, nope. How about 12,960 so far. I better go back and reread to make sure I got everything all set. Because that's not going to cool the full room down. Anybody? Why not? Keep going here. Keep going. Why isn't that going to cool the whole room yet? I still have to account for, George,
4 windows.
4 windows, right? How many BTUs a window? 1,000, I got 4 of them, right? So I have to add in 4 windows, 1,000 BTUs a window, and add that into the 12,960. So total BTUs, 16,960. Wow. Everyone all right on that? And that's nothing until we get to this last problem. Anything I can answer? We're all right? Okay. Well, I'll let you read through example 3. This has a lot going on, example 3. A lot going on. All right, everyone read it through. Can this trailer hold 500 bricks or not? And you're going to have to show me the calculations. What would it be nice to know about a brick? What are we going to have to figure out about a brick? Well, even to see if I can have 500 bricks in this trailer, what am I going to have to know about a brick? Yeah, how much it weighs, right? How much does one brick weigh, so I can multiply it by 500 and see how it compares to 900. Everyone agree? So in the density formula, what am I going to have to solve for? Mass, yeah. Okay, problem though. Right off the bat, somebody here, what's the density of the brick? 1,920, keep reading, kilograms per meter cubed. That's a problem right before we start. Why? Anybody see why? Because the brick is in centimeters. You can't do anything until it's all in the same units. Everyone got me? So does everyone see that? The density has to match the object's measurements, which everyone see why it does it. Density is in meters cubed, the darn brick is in centimeters. So we need to convert centimeters, all 3 of those centimeters, into meters. Anybody know the conversion? I'll give it to you. I'll always give it to you, and if I don't give it to you, it's on the formula sheet, which I don't think this one is. So I'm going to have to give it to you. Anybody know it though? Want to show off how many centimeters, centimeters? Yep. All right, 100 centimeters in a meter. So this is where we're going to start this problem off. We notice density does not match the object's measurements, so we have to change it. Hey, and I'm serious, you have to change it at the beginning. You cannot find the volume and change it. It's not going to work. All right, you got to change it at the very beginning. So here's our first. 1 meter equals 100 centimeters. So the first thing we'll do, let's take 5.1 and convert it to meters. So where should I put the 5.1 here? 15. Where should I put the 5.1 underneath? Underneath the centimeters, because it's in centimeters. And let's find out how many meters it is. So cross multiply. And then you'll figure out what the pattern is, and maybe you don't have to set up a couple more proportions. 5.1 centimeters is equal to how many meters? 12? 19? You're cross multiplying, right? Ellie, you got a 100x equals 5.1, and then divide both sides by 100. So you should be doing 5.1 divided by 100 to solve for x. 0.051 meters. There you go. There's my 1. If you guys want to keep going, go ahead. Do it again, but for 10.2. And maybe some of you guys see the pattern. And you don't have to keep setting up a proportion. Great if you do. If not, keep going. But all those three have to be turned into meters. Yes.
Is it possible to just, like, in another scenario, to divide the mass, like, divide the meters into centimeters instead?
Divide them. So you're saying take the density
Yeah.
and divide by. But here's the thing, Romeo. We have, and this is why I want you guys to do this at the beginning and not the end. We have this conversion, right? But it is not the same if I do this. That is not a true conversion. Okay? Just because I put the cube with it, they're not equal anymore. The 1 cubic meter is actually equal to 100, whatever 100 cubed is. You could do it that way, but these two, this is not equal. Okay? All right, everybody good here? Everyone got them converted? 0.051, 0.102, 0.203. All right, you told us I should probably find the weight of a brick, right? The mass. All right, so density equals M over V. Now that it's in the same units, density, 1920, equals mass over, can you find the volume of the brick now? With your new converted units. How do you find the dimensions of the, how do you find the volume of the brick? 17, talk to me. Volume of the brick?
You multiply the three numbers you just got.
Yep. So volume, 0.051 times 0.102 times 0.203. Don't round anything. You guys know better than that. Yeah, it's a small number, but that's what I wanted. Plug it in. For volume. If it helps, if your helps, put 1920 over 1. Cross multiply. Cross multiply. So one brick, 2.02753152. And now here's a big question for you. What type of units is this in? Look at the density, it'll tell you. We just used the 1920. What type of units was it in? Mass units. Kilograms. So this will be in kilograms, yeah. Whatever the density was in, that's what your masses will be in. Is there a need for me to change kilograms, or is that what the trailer's in? Okay, take a look, because sometimes I change the mass on you at the end, and you got to convert it before you finish the problem. But the trailer's in kilograms, and so is my brick. But the only thing now, what do I need to do with this 2.02 to figure out 500 bricks? 16, how do I figure out how many 500 bricks away? Yep, multiply it by 500. And we'll figure out if the trailer can hold it or not, right? I won't even write out because it's not even necessary. I think we can figure out without writing out the whole decimal. What is it, about 1,014 kilograms for 500 bricks? So will it hold? No, it will not. Trailer will not hold 500 bricks. So watch. Hey, ready? Let me just go over this one last time, because you're going to see different types of problems right now as I let you go on your own. If you're going to use D equals M over V, make sure the density measurements and the object's measurements are the same. If not, convert it now. At the end, when you solve for mass, because look, honestly, most of these problems you're going to solve for mass. When you solve for m, look at the density. The density will tell you what the mass is in. Kilograms in this case. Does it match what the rest of the problem is in? If it's not, convert it at that point in the problem. All right, go ahead. I'm going to stop talking and you're going to start doing. Work with anybody around you. I know these aren't tough. I know these aren't tough. Or are tough, excuse me. You only have to put up with the heat for today.